The electrical system consists of 3 separate subsystems: a DC direct current, which provides 28-volt DC from the starter generators, and 24 volts DC from the batteries. There is an AC alternating current of constant frequency, which is of 115 volt AC 400 hertz single phase from the static inverters. There's 26 volts AC 400 hertz single phase from the static inverters. There's also a frequency wild AC, which it depends on the actual speed of the propeller. Okay, so the faster it goes, the more voltage. Yeah, but it doesn't matter. It goes between 115 and 200. It's frequency wild and gets adjusted later on for the end users. Okay, it's usually used for stuff like the de-icing and the heating systems, as well as the electro-hydraulic pumps. Electro-hydraulic pumps. All the electrics are controlled from this one single panel. So you can see the DC part of it. If we have a look at here, is the battery. So you can put it from the off position to the on position, and then you'll have DC. Okay, once the DC is on, you'll have some basic systems, and we'll see in a minute. Then you have the AC system. You can have DC system coming from the generators. DC generator 2 for engine 2. Here, DC generator 1 from engine 1. And then the DC would effectively go onto DC bus 2 for the on-side engine. Come up this way up to here to an inverter. The inverter converts DC to AC. So post this inverter, the DC would now be AC. Okay, and then you'd have DC buses supplied, DC1, DC2, AC buses supplied, AC1, AC2. Okay, with at any time a bus tie here, bus tie contactor through a switch, which in its normal operation keeps this isolated. But at any time, if you lost number 2 generator, for example, therefore number 2 DC system, through operation of this bus tie contactor, number 1 DC would supply number 2 bus. Okay, so it's really, it's all automatic. No switching has to be done in terms of bringing buses back to life. It's a really good system, and the level of this is just to give you an overview. Okay, we do have also frequency wild that will go through to a transformer rectifier unit. Okay, it gets transformed and rectified into the systems that need it. Here are the 2 batteries. The batteries also supply DC to the system. And here we can see the actual amount of DC discharge. Okay, so that we know that the batteries are going into negative. Usually when the engines are running and everything's working, the propellers, the DC coming from the propellers is pumping in charge for the batteries, just like your car, and it would never go flat. However, if there was a situation where the battery was beginning to be defective, then the discharge, the battery would be losing more power than we're adding to it, and therefore this discharge would go into a negative figure, and we'd have to then troubleshoot it as engineers to find out what the problem is, because the batteries on this, they have to work. It's not like your car. If the battery doesn't work and it conks out, you just pull over or push it to the side of the road. The battery is the last resort of electrical power on the system, and if it has to legally be operational for 30 minutes after you've lost all of your electrical power on the aircraft. So the condition of them have to be fully charged at all times. Okay, so here are some displays on how the system is indicated or displayed. In the left one, you see the electrical system display is only the battery is on. Okay, so the two batteries are on as long as the bus tie contactor is in operation. In other words, it's making everything available, and through to the inverter, I can have a little bit of AC as well. I've inverted DC into AC now, and that will supply the AC standby bus. Okay, the AC standby bus and the emergency DC buses, because all my power sources are only from the two batteries. It's got a very logical sequence, a very logical display in that everything that's green is operational and actually there, and anything that's yellow is not available or defective or switched off. Okay. In the right-hand picture, we can see the electrical. We're sort of the same sort of constellation, but now we have external power as well. All right, we have external power available. Available means it's there. You have to switch the power on. This is what's displayed, and telling the pilot if you want to switch it on. Push the push button, the external DC push button, to make it available, to make it, put it on, basically, so that you will therefore not be using your batteries anymore. You'll be using the external DC supply. Okay, that will put the power on and also charge your batteries. This is what it would be. This is what it would look like. The switching unit. Now here, this the electrical panel. This here you wouldn't have both on at the same time. You'd have the available light like we had, and by pressing the available light on the external power on the electrical power panel, the available light would be changed from a green available indication to a blue on indication. Okay, and then you'd have your DC power, not from the engines now, but through the bus tie contactor to DC bus 2 and DC bus 1, and AC through the respective inverters. Oh, you wouldn't yet. You wouldn't yet, because only the DC is selected on. So you'd only have DC at this moment. All right. So here we have the so-called hotel mode. 1 minute, guys. The hotel mode, we said, is a running engine number 2 with the propeller braked. So the DC generator produces electricity and goes directly to bus 2 and via an inverter to AC bus 2. And it also goes via the bus tie contactor. Because this one is not running, it supplies DC bus 1 from generator 2, and then via inverter number 1 to the on-side AC bus 1. Okay, so it provides all the DC and AC electrical power that we need to operate the aircraft on the ground during a turnaround. All right, so we said green is good. And here is what you'd get with both engines running on the ground or in the air. Everything's available. Everything's working. It's a nice picture. This is what you want to see. And this is what you'd see when both DC generators would be unable to supply DC. Okay. If both engines were unable to supply DC, then the only DC supply would be from the batteries. Okay. And also from the AC wild through a transformer rectifier unit would be able to supply some DC on the standby bus. Okay. And also the AC wild will be able to provide via inverter number one some AC standby power as well. All right. So we can see we've still got AC and DC power on the aircraft. However, it would be a little bit limited, and you'd have automatic load shedding. You see these sheds, everything that's yellow means the systems will start chopping down the users in order to make it, in order to conserve the energy for the systems that actually need the electrical power now.